Hello, so today we are going to solve this binary tree maximum path sum problem from Leetcode 30-day challenge. So the problem says given a non-empty binary tree, we want to find the maximum path sum. So we have a non-empty binary tree and we want to find the maximum path sum. A path is defined as any sequence of node from some starting node to any node in the tree along the parent-child connections, okay? And the path must contain at least one node and does not need to go through the root. So we don't have to go through the root because maybe the root is the negative value and going through it will give us a smaller sum. So for here, we just go through the entire tree, 2, 1, 3, which gives us 6. Here, this gives us -1, and then, so, well, actually just 15, 27. If we go by this route, we'll get a smaller value because the sum here and here is -1. So it's better to just take 20, and then this here is 22, so we get 42. So how can we solve this? So this is a binary tree, right? Let's write down what we know. So this is a binary tree, which means we can probably do some kind of DFS. I'm thinking basically consider every node as a root, as possible root, and just pick the maximum of the sum of each. Max sum of each of a subtree of each subtree, right? So what would that look like? So what we have is something where we could do node dot left, node dot right, right now, and then we could maybe add node dot val plus something, right? And then we could have max either as self dot max or pass it as a parameter, or we could have it also as a return value, right? So which one can we do here? So for each one, we want to calculate the sum of the subtree itself and compare it with the max, but we want to also return the sum. Actually, each subtree needs to return the max to the parent. That way the parent gets the max and compare it with itself. I'm thinking you can't have. So the path is any sequence of nodes from some starting node to any node in the tree along the parent-child connection. So does this mean that you could have, so you could have minus, if this was like 10 and this was, let's say, minus 11 or something, you could still take these and get a better answer, but you can't just jump and skip a node, right? So what this means is that we could take these two, right? I think that will complicate things. Let's skip it for now. So what we said is the from any node to any node, right? yeah, let's try with the self.max equal to 0 thing. So define a helper with a node that says helper node.left and then node.right, and so we say node.var plus, and then here if not node, we should return 0, and then if not, so we have that sum, and what else can we do? So we need to take max Okay, it looks good with that one. Let's try with this one. Okay, looks good. Let's try with an empty one. Okay, for an empty list, it somehow returns an infinite value, which means that this here was initialized to float infinity. That's fine. I mean, we could do that. Or we could just take this value. So this one should be 2, but my output went ahead and gave -1. So for some reason it's not working for 2 minus 1. So let's see what we may have done wrong. I'm just going to go with float. So this means here that at some point when we reached S here, we returned it, it somehow said the max 1 was better than 2. Or I just do it for children, I never do it for the node itself, right? So yeah. Actually, we should also do it for just the node and the left side. So we should do something like this. And for same thing. So let's call this left sum. Okay, let's call it actually left path, right path. So we could do this, and this is the full path, and okay, let's try to submit. So what we are doing here is we check the full path, left path, and right path, but seems like it's wrong here. So 55, 1, 4, so this is 5. I mean, the entire thing should be taken into account. So 2, 7, that's 9. 11, that's 11, that's 20, 24, 29, 29, 8, that's 37, 37, 37, 13, 37, 13, that's 50, and then 55. So, I mean, my output seems correct, unless there is something. Yeah, you can't do like the entire, that's not a path actually. You can't do 7, 2. You have to do 7, 11, 4, 5, 8, and 4, 1. You can't go right and left, you know? So that's the problem there. It has to be a path. If you go like left and right, you can't. Yeah, okay. Interesting. So at the left path, right path. So the problem is returning this here. Okay, maybe I should pass the sum here. That way we could return max of node.val either the left path The problem is I don't know how to include this without recursing to the parent and having the parent tag itself to it, right? Maybe we could have something like subtree path and do this plus this. Okay, so I'm thinking let's go back to using this self max with this, but here I'll just like to change it one bit. So we want to pick it only if it's bigger than 0, because otherwise we won't get a good answer. And then with the self.max sum, we could consider this, right? This we can consider it only alone, so there is no need to return it to the parent. And we can have left path, right path here, check among these three, and then return the max between the left path and the right path to the parent, so it can reuse it. Okay, this looks reasonable. Yeah, we don't need to do this as here. Okay, cool. Oh yeah, sorry. This is equal to max of that and whatever was there before. One thing is, let's just put this in a variable, call it this left, and then call this right. So we could say left here, and then this is right, and then here this would be left. Actually, let's just keep that the way it is. It was fine, I think. Okay, so we have left path, right path, subtree path, and then the max sum of all of them, and then we return the left path or right path. Good. Okay, this looks good. Let's try to submit. Okay, time limit exceeded for this use case. Let's see what could be wrong. Yeah, why am I doing this again? I should be left path and then right path. Okay, this should be left. Let's go back to that. And this should be right. Okay. Of course, max 0, and let's go left, and then right. That way we do it only once. And here we could do left, right, and that's pretty much it. So let's try to bring that here. So we're doing it once, taking the left path or right path or the subtree path and the max of all of them. Okay, looks like it was passed. Okay, so that's accepted. Cool. Yeah, so trying the left path, right path, the subtree path, taking the max, and the parent, since it can continue only with the left path or right path, we pass the maximum of the two. And that's pretty much it for this problem. Yep, cool.